All right, let's look at number 9. Using the activity series in table 8-3 on page 266, predict whether each of the possible reactions listed below will occur. For the reactions that will occur, write the products and balance the equation. And for the reactions that will not occur, write no reactions. So what we're doing here is we are most certainly needing access to this table listed on 266. If you do not have your table open to this problem, you're not going to be able to complete the problem. So you're putting yourself at a huge disadvantage here. Do not attempt to memorize this list. It's just going to go poorly for you. Don't do it. Just open up to the list. So what we have here is a bunch of potential single displacement reactions and then some oxidations. So let's see if those are going to occur. So the two elements that are going to potentially undergo replacement are going to be nickel and copper. Okay, not nickel and chlorine because, well, they're not similar elements. Remember, only similar elements can displace similar elements. And so as I look through the activity series, nickel. All right, so I see nickel is on top of copper. Okay, so nickel comes before copper on that activity series. So that does mean the reaction will occur. So I'm going to have some nickel chloride. That's going to be in the aqueous stage. And then what got booted is going to be right by itself. And in terms of balancing, I think we're good already there. All right, for B, the potential replacement is going to be zinc and then lead. So we look at the activity series. Which metal do we come to first? Do we see zinc first in that list, or do we see lead? And in fact, we see zinc first. So zinc is more active than lead. So zinc will actually undergo this displacement. So we'll have some zinc nitrate. Zinc's a +2, so I need 2 nitrates to balance that out. And that's in the aqueous state. And then what got booted is by itself. Lead just by itself. All right, see, do we need any coefficients here? Nope, that one is already balanced. We're good to go. C, the question is whether or not chlorine will displace iodine. That is the issue here. Now, we're not dealing with the metals here. It's only one metal. We have 2 halogens. So let's check the activity series for the halogens. And we are going to see that chlorine is, in fact, more active than iodine. So chlorine will displace the iodine. So what I'm going to have here is some KCl, and whatever got booted is going to be by itself. Now, iodine is a diatomic molecule, so I know it needs to be I2. Throw some coefficients on there to make sure that that's balanced. Let's see. Oh, I didn't do states phase. Aqueous, and let's see. In this one, this is going to be in the solid. All right. Let's see. Copper and then an iron sulfate. Let's see. So the 2 elements that may undergo displacement are going to be copper and or iron. So let's check here. Which one am I going to come to first? Copper, iron. I'm coming to iron first. And so that means that iron is actually more active than copper. Okay, iron is more active than copper. So I'm going to go no reaction. Now, the next 3 are all oxidation reactions. Okay, they're all combustion. Combustion is another word for that type of reaction. The question is, are each of these metals active enough to react with oxygen directly? And so what you can do here is you can go down to the very bottom of your activity series. The elements listed here, silver, platinum, gold. It says fairly unreactive, forming oxides only indirectly. And what that means is, well, you got to help them. Okay, you have to do the work for it in the lab. You have to use some sort of catalyst or something like that. And so if the metal that's proposed supposedly going to react with the oxygen, as long as it's not in that lowest that lowest box, the lowest activity box, this is going to happen, okay? Because the next box up says reacts with oxygen, forming oxides. So, calcium. Calcium is actually up towards the top in the first box, so this is definitely going to happen. So we're going to get calcium oxide, okay? Nickel. Nickel is in the third box, okay? So it's not going to react with water. It'll still react with acids, and it most certainly will react with oxygen to make that metal oxide. Gold, however, is down there at the very, very bottom, so that's not actually going to happen. And so we're simply going to write no reaction. And one of the things that we really need to look out for here is the no reaction situation. I may ask you a question on the quiz or on the test where there's a proposed single displacement reaction, and I ask you to predict the product, and that's fine. That's good enough. There's no problem with that to predict potential products. But then when I ask you, for example, if you have 1 mole of this particular reactant, how much product is going to be produced? If the reaction doesn't occur, there's no conversion to be had. There's no conversion to actually do because the reaction won't happen. Whatever amount of the product that I gave you isn't going to react. Let's see here. All right, looks actually, I made a little bit of boo-boo. I didn't actually balance this, so this needs to be 2. That needs to be 2, 2, 2. And what are these going to be? These are metal oxides, so they're going to be solid. Okay, so now we're good and balanced.